Positive 12 to 18 volt are applied on these lines. Here is 150 ohm half watt or 1 watt resistor, 12 volt battery monitoring circuit. We will use this circuit to monitor the battery voltage. This circuit can be used to cut off the battery at full charging, and if the battery is below allowed threshold, that is 14.3 volt, it will give us charging sign. When battery is above 14.3 volt, then it will give us fully charged. We can control any relay, any MOSFET. Let's design this circuit. We will calculate its all parameters. So using these calculations, you can use this circuit to monitor 24 volt, 48 volt, whatsoever. We will use LM324, very commonly used operational amplifier IC, as a comparator. You can also use transistor, you can also use LM339 voltage comparator, but we will use LM324. Let's start. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf, and I welcome you on my YouTube channel. We need LM324 IC. It is 14 pin. Pin number 11, ground. It is common for all sections. It is 4-channel IC. There are 4 operational amplifiers in this IC. Pin number 4, positive voltage. If you want to monitor just 12 volt battery, that time we can connect directly to the battery voltage. But it is best to use a Zener regulator to apply voltage to this IC. 12 volt 1 watt Zener. You can use half watt, 1 watt. Anode grounded, BZX85C12. We need a series resistor to connect with Zener. Now we need to calculate this resistor value. This BZX85C12, it can handle up to 120 milliampere current. But we will not use at full range. We will design it at 40 milliampere. We need a resistor V supply minus V Zener divided by I Zener. Supply voltage. We need to remember here we are monitoring battery. If battery is disconnected from the circuit, charger voltage up to 18 volt, 16, 17 volt, that are nominal. So we will consider 18 volt. That is maximum limit, minus V Zener, 12 volt divided by I Zener, 0.04, 40 milliampere. It is 150 ohm resistor. When we are selecting resistor, the very important parameter, that is power rating. 150 ohm, how much current? 0.04 square. P is equal to I square R, 0.24 watt. But we will use half watt for safe operation. I will use this 1 watt resistor. Anode grounded, 150 ohm resistor to the supply line, positive side. So we will take 12 volt from this Zener diode and we will apply to pin number 4 up to 18 volt. To operate this IC we need 2 signals. One is reference signal, the second is sense signal. To make a reference signal, we will use 4.3 volt Zener, the same 18 volt line, that is battery line. This will be connected here. We will design this Zener circuit around 10 milliampere, 15 milliampere, because there is no load. The same 0.015 ampere. We supply 18 minus Zener voltage 4.3 divided by 0.015, 913 ohm. So we will use 1K resistor, 1000 ohms multiply 0.015 square 0.225. This is power rating, 0.225 watt. So we will use half watt. This time I have quarter watt, I will use quarter watt. Pin number 11 will be grounded. And we will feed this signal to pin number 2, that is inverting input. 4.3 volt Zener with 1K resistor. This center node will be connected to pin number 2. Now we have reference signal to monitor the output. If we want to see on LEDs, we will connect LED. For safe operation, if we use 10K resistor, that is very safe for operational amplifier. But this time I am just demonstrating, so I will use 1K resistor. Otherwise 3.3K, 4.7K, up to 10K, that's nice when we are using 12 volt power supply. Otherwise we need an amplifier transistor to amplify its output signal. Now we need sense signal. We need a voltage divider network. We will connect same battery line here. We need to sense 14.3 volt instead of 18 volt. We will connect the same line, but now we will consider 14.3 volt at 1 milliampere. That's nice. If we use to sense 14.3 volt divided by 0.001, 14.3K total resistance here. We need 4.3 volt across low side resistor here. Total resistance 14.3K, and we need VR2 4.3 volt. We can calculate the resistor value. 4.3 divided by 0.001, 4.3K resistor. The low side resistor 4.3K with the same formula. Here we will use 10K. To make it adjustable, we will use 3.3K standard resistor with 2K potentiometer. 3.3K, and this is variable resistor. So we will use 2K trim pot. When voltage will reach 14.3 volt, this signal will 4.3 volt and it will reach to pin number 3. I will use 10K resistor positive side, and I will use 2K potentiometer. We need 3.3K resistor. One side this resistor to the ground side. With combination of this resistor and this variable resistor, we will adjust 4.3 kilo ohm and this 10K resistor to the center slider arm and positive line. Now this point, this node, it will reach to pin number 3. I will connect 1K resistor, LED anode side, cathode is grounded, and we will connect 1 mega ohm resistor between so it will protect the IC from intermittent operation. Pin number 1 to pin number 3, I connected a resistor 1 mega ohm. It is now non-inverting amplifier. When voltage will increase then this limit, it will provide output. Now we will design another section. 1 kilo ohm resistor. We will use these both signals. We will feed to this operational amplifier section, but we will invert these signals. That Here we connected at pin number 3, that is non-inverting input. Now we will connect to inverting input. In this section, inverting input is pin number 6. This signal now we will connect to pin number 5. Pin number 7 is output. And we will connect 1 mega ohm resistor between pin number 7 and pin number 5. Pin 2 is connected to pin 5. So both sections will work opposite to each other. Pin 2 to pin 5, pin 3 to pin 6. Here is pin number 3. It will reach to pin number 6. We need 1 mega ohm resistor between pin number 7 and pin number 5. When we are using operational amplifier as a comparator, it is important to use a high value resistor above than 470k to 1 mega ohm. I will use voltage booster module to give variable voltage. If you have external power supply, you can use it. For experiment, I will simulate the battery voltage using this module. Let's supply power. Positive, common. This is a final circuit diagram. You can take screenshot. Positive 12 to 18 volt are applied on these lines. Here is 150 ohm half watt or 1 watt resistor, 12 volt Zener anode grounded. It will provide regulated 12 volt to pin number 4 of this IC. Pin number 11 of this IC is grounded. Here we have 4.3 volt Zener reference. It will provide 4.2 to 4.4 volt, nominal voltage 4.3. These voltage are passed to pin number 2 and pin number 5. Here inverting input, here non-inverting input. So reference is applied opposite in both sections. Then we have sense line. This resistor 10 kilo ohm, 2K potentiometer, and this 3.3 kilo ohm. Why we use potentiometer? It is to compensate the Zener tolerance and these component tolerance. So using this potentiometer, we will able to adjust the battery cutoff at our required voltage level. We can also trigger any MOSFET, any relay to control the charging. So this LED will show charging and it will show charged. If you connect this signal to any MOSFET to control charging process, when the battery will full, this signal will be disconnected, charging will stop, and this circuit will show fully charged. Let's test this circuit now. Common. We have 14.2 volt at positive line. 12 volt Zener is regulating 12.7 volt. This Zener is 4.4 volt. First we will set our required voltage value. Now we will set this potentiometer to turn off this LED and show charging process. Yes, this is trigger point. We will rotate to just turn off this and turn on this. Yes. Now if voltage will drop from this point, Now we will check what is the exact trigger point. Perfect. Approximately 14.34, 14.35. It is switching. If we need, we can adjust this potentiometer, this trim part, to obtain our required value. If you think this video is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.